All right, so on number 15 here we have to determine whether these are divisors of 12. And since it's an even number, it certainly is divisible by 2. And if you add up the digits, 2 and 3 is 5, another 5 is 10, 16, 17, and 8 is 25, and another 8 is 33. 33 is divisible by 3, and so this whole number is. For 4, we just look at the last 2 digits, and of course 88 is divisible by 4. We end in an 8, so that's not going to be divisible by 5. Since it was divisible by 2 and 3, it'll be divisible by 6. And the way it works with 8 is if the last 3 digits are divisible by 8, then the whole number is, let's see, 188 divide 8. That's not going to work, so 8 doesn't work. We said that some of the digits was 33. That's not divisible by 9, so 9 doesn't work. And of course 10 doesn't work. And so these are going to be I missed 12. 12 is going to work since 3 and 4 did. And so that would be option C. It's not the greatest problem for a final. You could certainly double check things on your calculator, but the whole idea is to know these rules so you can do things quicker without a calculator. All right, let's look at number 16. It says, express the sentence as a single numerical expression, then use the order of operations to simplify the expression. So we would start by subtracting 25 from 22. That's how you would write that. Multiply this difference by 3. So we're going to want to do that. You need to have this in parentheses. Raise this product to the 4th power. So that product to the 4th power, that's what we're looking at here. And that would be option A, or the first one here. Let's look at number 17. A will states that 2/3 of the estate is divided among the relatives of the remaining estate. Well, if 2/3 is to be divided among the relatives, that leaves 1/3. That's what's remaining. So of that remaining, that 1/3 that's remaining, 1/8 goes to a certain charity. By the way, it's not hard to see this. 1 represents the whole thing. Oops, let's clear this. 1. And if we subtract the 2/3 that goes to the family, you can use the fraction button here. When you hit, well, let's go ahead and just arrow over 1 minus 2/3. When you hit enter, you do get 1/3. But hopefully you can do that without a calculator. So of the remaining estate, 1/8 goes to a certain charity. So basically 1/8 of 1/3, which is the remaining part of the estate, goes to charity. And so anytime you take 1/8 of 1/3, this of indicates you're going to need to multiply. And so you get 1/24. All right, let's move down to number 18. The national debt of a small country is 724 billion. Let's go ahead and write that number. And make sure that's 724,000. That would be 724 million. So this would be billion. And we're going to go ahead and write that as 7.24 times, let's see, our decimal has been moved 3, 6, 9, 10, 11 times. So this can be written as 7.24 times 10 to the 11th. The whole point of this problem is we want you to be able to use scientific notation. As numbers get bigger, you can't always get them into a calculator, And so we have to put them in scientific notation in order to do the arithmetic. Okay, so the population is 2,957,000. And this is the amount they owe. What is the amount of debt per person? So the debt per person, that's a ratio, debt per person. In this case, well actually let me write this number here in scientific notation. This time we would move 6 times to the left, so this will be 2.957 times 10 to the 6th power. And so our debt is 7.24 times 10 to the 11th, and we're going to divide that by the number of people, 2.957 times 10 to the 6th. And I'm going to go ahead and put these into the calculator. Now, I think there's a way to do it so that everything's in scientific notation, but I wasn't finding how to do that, so I'll show you how we're going to do it. Oops. Okay, so let's hit the fraction button first, and we'll use parentheses. 7.24 times 10 to the 11th power. This is our exponent button. Arrow over and parenthesis, and we're going to divide that by 2.957 times 10 to the 6th power. And let's see what we get. So we're not getting it in scientific notation. It's 244,842.746. Now this is going to be a certain amount per person. It looks like it's $244,842.75 basically. But they want us to write the answer in scientific notation, so we go 1, 2, 3, 4, 5. There should be one digit to the left of the decimal. So this is 2.448. It looks like they rounded right there. Times 10 to the, and we said we want 1, 2, 3, 4, 5 times. And so that's your final answer, which is option B. All right, let's move on to number 19. Now, we had talked about how when you're dealing with percents, often you deal with what I call the percent equation. Basically, the percent equation says you take, or some percent of a number equals another number. And so you can actually just translate this problem. It's 161.7 is or equals what percent, that's going to be our, let's go ahead and call it n, of or times 66. So basically it's a percent of or times some number equals some other number. Oops, so if we're basically solving 66n equals 161.7. So here to get n by itself, you have 66 times n. You want to do the opposite of multiplying by 66, which is dividing by 66. And you will get 2.45. Now remember, this is a percent. If you move the decimal 2 to the right, you get 245%, which is option A. Notice this makes sense. Usually when you take a percent of a number, you get a smaller number, but since the percent is more than 100%, that's why we're getting a bigger number. All right, number 20. A bank offers a CD that pays a simple interest rate of 6%. How much do you put in this CD now in order to have $10,360 to replace all the windows in your house in 8 years? Well, first of all, this is simple interest that we're dealing with. And notice we're not just finding the simple interest. In fact, how much must you put in the CD? That's the starting amount, which we usually call P, or the present value, in order to get this amount, which we would call A, or the future value. So we're going to use this equation here. We only have two for simple interest, and this is the one that deals with future value and present value. And so in this case, A is 10,360. We don't know P. R is 0.06. This is written as a decimal, times the time, which is 8 years. And so if you multiply this out, you get 10,360 is equal to P times 1.48. So what we really have is 1.48p. Notice I like my variable on the left. It really doesn't matter though. I'm just switching sides here. And so again, we have some number times p to get rid of that number so we can get p by itself. We'll divide each side by 1.48. And so we get p is equal to $7,000. And by the way, you could always plug in 7,000 here and multiply by this, and you should get 10,360. You can verify that is true. Let's look at number 21. And I had a formula sheet around here, and I don't know if I still have it. I'll just refer you to the formula sheet. When you look at the formula sheet, let's see what I want to say here. It's going to be one of these two because you're dealing, well, let's just look at the problem. It says James and Susan wish to have $10,000 available. In other words, that's the future value. That's what they want this money to be worth in 2 years. How much money should they set aside now? Well, how much money should they set aside now? That's your present value. And at 6% compounded monthly, notice this is compounded n times per year, or 12 times per year. In other words, n is 12, in order to reach their financial goal. Now, if you look at the the equations or the formulas, the financial formulas, there's one for financial goals with the lump sum. And that's the one we're going to use here because we have a financial goal. We need $10,000 in 2 years. We need to know how much we need to invest now, the present value P, in order to, so basically we're finding P. This is the one we're going to be using. So A is 10,000. This will be divided by 1 plus 0.06. N here is 12 because it's 12 times per year. The interest is compounded. And let's see, 12 times the time, which is 2. So that's what we need to plug into our calculator. So I'll go ahead and do that right here. So first of all, let's hit the fraction button. oops, let's turn this thing on. So the fraction button, got 10,000. And then arrow down. And in parentheses, we'll have 1 plus, and I would do 0.06 and then hit the fraction button over 12. And let's get out of there and do parentheses, and then the exponent button, which is right here. And then, now 12 times 2 is 24, but I'm going to go ahead and write 12 times 2. And you can see that it's in it's in the exponent here. On some calculators, you would have to put 12 times 2 in parentheses, or you would have to just put 24 there. You got to be careful because of order of operations. So I'm going to arrow out of there. You can see it looks just like it does on paper. So it's easy to check that you put in all the numbers right. And you get $8,871.86, which is B. All right, let's look at 22. Find the value of the annuity and the interest. Round to the nearest dollar. Now, annuity is different than what we just did in the last problem. In the last problem, it was dealing with a lump sum. Notice we had to put away $8,871.86. Now, how many of us have that kind of money hanging around? Normally, if we're trying to save money for future things, we'll put aside money each month. That's quite common, or at least on a regular basis. And so this is what we call an annuity, where we're saving a set amount every month or perhaps every year. Those are probably the most common. And in fact, you can see here that this is going to be compounded annually. And we're putting in $1,000 at the end of each year. So a lot of times people will do this at the end of the year because it's tax time, and they'll figure out how much money they want to save. And that can sometimes help them with their taxes to lower their tax burden for the year. Notice our time is 14 years. So if you look at the formulas for annuities, this is the one we're going to want because, well, first of all, the 1,000 that we're putting in at the end of each year, that's our P. See, we want to find the value of the annuity. Really what that is, the future value, that's going to be A. And so that tells us it's one of these first two. But because it's compounded annually, we use this one. If it had been compounded monthly, or maybe every 6 months, then N would have been 12 or 2, and we would have used this one. Because it's annually, we use this one here. And you can verify that on your formula sheet. It says annuity for annuities that are compounded per year. All right, so let's go ahead and write down the formula. So here our P is 1,000 times 1 plus our interest rate, which is 4.5%. We'll move that decimal 2 to the left, and we get 0.045 to the T power, which is 14 years, minus 1. And that's all over R, which is 0.045. All right, so you just want to make sure you can put that in the calculator correctly. Let's go ahead and do that. So again, I'll hit my fraction button first. I'll do 1,000 parentheses 1 plus 0.045 into parentheses exponent button to the 14th power. Don't forget to arrow to the right, minus 1 into parentheses. And then let's go down to the denominator here. Notice our numerator looks just like we would, just like it does on paper, although you can't see the whole thing. Now you can. Whoops, there we go. All right, so 0.045 goes in the denominator. So you can see that you can't see the whole thing, but if you arrow right, you can see the -1 in the numerator. You won't always be able to see it all. It depends on how big your expression is. Let's go ahead and hit enter. Uh-oh, I made a mistake. Let's see, I gotta go back. Well, I guess there we go. Let's see what I did wrong here. So 1,000 times oh, I see what I did. I forgot my other parenthesis right here, because I had a parenthesis that goes around everything in here, including the -1, and then I have a parenthesis going around this. So I missed my parenthesis. Well, I didn't mean to do that on purpose, but that's a good thing to show you. So I'm going to insert another parenthesis, so I can hit second insert and type a parenthesis there. And now we're good. And let's go ahead and hit enter. And we get $18,932 and about 11 cents. It looks like they're rounding to the nearest dollar here. Now, because there's only one with that answer there, it's not too hard to figure out what the interest paid was. But I just want to show you real quick, this is not difficult. We put in $1,000 at the end of each year for 14 years. And so that would indicate we paid $14,000. If you subtract $14,000, that's our contribution, you'll get the $4,932. All right, so that's it for this video. I'm going to stop here and do one more video, and I'll finish up the review in that video.